Yo, what's up guys? So today we're going to be talking about my operating system, and specifically the move and the load functions. Today I'm going to be talking about how my operating system works overall, how I coded my move function with my own assembly language, how I coded my load function, and then finally a demo where I can show the computer working in action. So let's get started. So this is my operating system. Right now it is 249 lines out of the 256 available for my computer. So it's almost too large, so I'm not going to be able to add anything else. But once I get a larger, better computer, I can have more commands. I can have more lines. And before I talk about the move and load functions, I want to talk about how this operating system works. So it starts off pretty simple. It just clears everything basically. It sets the function to addition and then just clears the temporary register and then accumulator and then jumps over all of this stuff to line 43. And in this program it's line 44. And all this stuff is all the functions for my computer. And so this way I don't repeat code, so I can just call the function whenever I want to and it will run a certain series of commands, so I don't have to constantly be replicating it. Now here we go to line 44, it just skips over this call 35, which runs the function that gets the current position from RAM, and then it just clears everything, sets the function to addition, and then here loads R795, and that is simply just an underscore. And this is going to pop up at whatever position it wants me to type to, and so you can see that this is very repetitive here, and all it does is it outputs this R7, and then it takes an input and stores it to one of the registers. And then here there's this call 5, which just prints the character to the screen, the one you typed in, and then moves the character position over one to the right. And so this repeats, so we get register 0, register 1, 2, 3, 4, all the way up to R7. And you notice this actually overwrites the underscore, but it's fine because we're not going to use it anymore until later. And then here it takes the current position and stores it to 10, so cell 10 in RAM. And this chunk right here identifies which operation it is. So what it does is it basically takes the first two characters, which is the identifier, the ID of what operation you're doing, and it adds them together. And so then it does a bunch of comparing operations to check what their sum is, and if their sum is equal, then it will run that instruction. So that was just the easiest way I could find. Instead of doing a bunch of if statements for single letters, I could just add them all together and basically have one level of verification, identifying which function it is. Now that I talked about how my operating system takes inputs and identifies which function you're using, let's talk about the move function. So this is my move function for my operating system. As you can see, it's very simple. It's only 9 lines, although it does call a function twice. It's very simple. It's just a move function for those who don't know. It just takes a value from one register, from one storage unit, from one piece of memory, and moves it to another register. But these registers are not the general purpose registers that I'm using here, like CR3, R2, R4. They're actually spots in RAM, and right now I'm only using 10 bytes of RAM for my registers, only 10 registers, R0 through R9. Now this call 9 does take a few arguments. First you have to move the R of the R whatever, like let's say we're using R0, you have to move the R to the temporary register, and then you have to move the number, the 0, to R2. It first verifies that you're using R, that you're using the correct syntax, and then it takes the number and subtracts 48. If you don't know the ASCII system, 0 in ASCII is 48, and then 1's 49, all the way up to 9, which is 57. So if I just subtract 48 from any of the numbers, it will convert it to an actual number. So then it would take 48, subtract 48, and we get zeros, which is what I put in. I put in R0. And then it moves that 0 or whatever number I'm using to the memory address register, which basically opens up RAM to that register. And then it just takes the value out of RAM. Now notice I'm using R6 and R7, which are the last two characters I typed in, and that is going to be the register that I'm taking from. So the first register I put in is the one I'm moving it to, the destination, and then the second one is the source, the one I'm grabbing it from. So then we basically grab the value from the first register, put it in R0, and then we set it up for the next call function. And then this opens up RAM, and then we just move R0 to RAM. So then we take the value from one register and put it into the other, and then this just goes back to the beginning of the program. So that's how my move function works. Let's look at the load function. Now this is the load function. It's a little longer than the move function, but it's still pretty simple. Now we see here there is the call 9, which just opens up the RAM to that specific register I put in. Now that opens the register, it gets ready for me to input my value, and most of this is just converting the hexadecimal digit into binary. So then this takes my first hexadecimal digit, and then it runs call 16, which it checks if it's A through F or 0 through 9, and then subtracts the right amount to convert it to an actual binary number. And then because this is the first digit, it shifts it up 4 bits. It takes it from the bottom 4 bits to the top 4 bits. Then it checks the second hexadecimal digit and converts it to binary. And then it simply just adds them together and stores it in RAM and then resets, goes back to the beginning. So let's run a demo. I first set the tick speed to 1000, which is just 50 times the regular speed, which is 20 ticks per second. Now I'm just running a basic load function where I am loading to the register R1 the value 1E, which is 30 in hexadecimal. So let's actually take a look inside the computer, and we can actually see where that 1E is stored. So in hexadecimal, 1E is the number 30. And it's just the 1 here in the 16th place, so it's 16 plus E, which represents 14, so that's 30. This chunk right here is register 0 through 7, and then here's 8 and 9 right here. So if we stored to, if I can look back here, we stored to register 1, 1E. So we go to register 1. The first 4 digits should be 0, 0, 0, 1, which is simply 1, right? So 0, 0, 0, 1. And these repeaters represent the bits, so when they're off, it's a 0, it's on, it's a 1, so 0, 0, 0, 1, so we know there's a 1 there. Now for the E, it's 14, which in binary, 14 is 1, 1, 1, 0, so the last 4 bits should be 1, 1, 1, 0. So 1, 1, 1, 0. There we go. So we can see that we've stored 1E in register 1. Now we can look at R0 right here. You can see it has some other value stored in here, so we see 3, and then 11, which is B, so 3B is stored in register 0. So let's move register 1 to register 0. Now I am running a move function, so here I'm writing the destination is going to be R0, and the source is R1, so it's moving the value stored in R1, which is 1E, to R0. So we have moved R1 to R0, and remember in R1 there was 1E, so we can go check out R0. So if we go over here to our RAM, we should have the exact same thing that was in R1, which is 0, 0, 0, 1 for the first 4 digits, 0, 0, 0, 1, and then we should have 1, 1, 1, 0 for the last 4 digits, 1, 1, 1, 0. There we go. So we have loaded the value 1E to a register 1 and then moved it into register 0. So instead of having to check the RAM each time and to make it a little more user-friendly, I made an output function where you just have to give it the register and it will output the data, the 2-digit hexadecimal number stored within that register. But that is a topic for another video. So that was a demo of how my load and my move function work and a little bit of how the operating system as a whole works. Next week I'll do a video on the output function, so explaining how that works. So stay tuned for that, but that's all for now. Peace.